Hello guys, welcome to Simple Math. This is your channel, and in this video I will explain how to calculate or how to solve an exercise by using difference of cubes. Okay, so this is the formula for different sum of difference of cubes. In this case, it's a difference of cubes. Maybe you don't understand this formula before I explain this exercise. The exercise is x raised to the 6th power minus 8 raised to the 12th power. First, we need to check if that is a common factor. If you see there is not a common factor, it's not a common factor by grouping because we need at least 4 terms, and um, and that's it. And the instruction is factorize, factorize. So if the exercise is neither a common factor nor a common factor by grouping, we try by using um, sum of difference of cubes. It's not a square difference because look, this has a square root. But what happened? Why is not a difference of cubes? Because the 8 does not have square root. There is not a number that multiplied by itself give us 8. 12 has square root, but 8 no. It doesn't have square root. So we cannot solve or we cannot factorize this by using a difference of cubes formula. So we try doing sum of difference of cubes. In this case, it's difference, and then we're going to follow the following. We will use the following steps. So we will check, after checking that is not all the other cases, we will check if this first term has cube root. Yes, if you see x exponent 6 has cube root, which is x exponent 2, and this term also has cube root. What is the cube root of 8? 2. 2 times 2 times 2 is 8. And the cube root of y exponent 12 is y exponent 4 because y exponent 4 times y exponent 4 times y exponent 4 is y exponent 12 because remember we add the exponents. So if that happens, we can use this formula. What is the formula about? I'm going to explain right now. So the first step is to open two parentheses. The first parenthesis is, let's say, a short parenthesis, yes, like this. And the other one is a big parenthesis. And I will explain why. Yes, that is the big parenthesis. So in the first parenthesis, we write plus in the half and, minus in the half. Minus. Yes, that is the always. That is the sign of the first parenthesis, which is the shortest one. And in the second parenthesis, we write plus and plus. That is the first step. Very similar to square difference, but in this case, we have a short parenthesis, and then we have a long parenthesis. The first parenthesis minus always when we have a difference of cubes. And in the other parenthesis, we write two plus signs inside the parenthesis, which is the next step. Sorry, which is the next step. The next step is to calculate the cube root of each term. So I'm going to calculate the cube root of x exponent 6, which is the cube root, of x exponent 6 is x exponent 2, because x exponent 2 times x exponent 2 times x exponent 2 give us x exponent 6. And in the same way, we will calculate the cube root of 8. What is the cube root of 8? The cube root of 8 is 2, because 2 times 2 times 2 is 8. What is the cube root of y exponent 12? Is y exponent 4. Because if we multiply y exponent 4 times y exponent 4 times y exponent 4, it gives us y exponent 12 because we add the exponent. Now, we will use the following strategy. Here, I'm going to write the cube root of the first one, which is x exponent 2. And then I'm going to write the other cube root, which is 2y exponent 4. So I copy here 2y exponent 4. Let me write it here. 2y exponent 4. 4. What is the next step? I'm going to take this element and I'm going to copy here, but raised to the second power. So I'll do it step by step. I'm going to change the color for you to understand in a better way. So, and I'm going to copy this term here, and I will raise to the second power. Yes, So I'm going to write here x exponent 2, and I will raise that to the second power. Yes, to the second power, like that. Then I'm going to take the second term and I'm going to write it here at the end. And I will do the same thing. I mean, I will take it and I will raise to the second power. So I'm going to write here 2y exponent 4, and I will raise that to the second power. Yes, I will raise the second term to the second power. And in the half, I will multiply this term by this term. So in the half, I'm going to multiply x exponent 2 times uh, 2y exponent 4. 2y exponent 4. Yes, I'm going to multiply the two things. The first parenthesis stays in the same way. So I'm going to write the same parenthesis, x exponent 2 times, sorry, minus 2y exponent 4. You see, it's the same parenthesis. And in the second parenthesis, I will solve the powers. If you see here, I have x exponent 2 raised to the second power. According to the property of exponents, we have to multiply the two exponents to get the answer. So let me open the parentheses. I open the parentheses. How much is 2 exponent 2 raised to the second power? We just multiply the exponent. So x exponent 2 raised to the second power is x exponent 4. We multiply the exponents plus how much is x exponent 2 times 2y exponent 4? The answer is 2. I will write it in order. 2 x exponent 2 y exponent 4 plus I have to solve this part. So if you notice, everything is raised to the second power. So 2, we have to solve 2 exponent 2. We have to solve that. 2 exponent 2 is 4. And what happened with these two exponents? This is y exponent 4 raised to the second power. We multiply the exponents. So in this case is, in this case is y raised to, how much is 4 times 2? 4 times 2 is 8. And then I close the parentheses. And that's the end of the exercise, because if you see, we cannot subtract unlike terms. And here we don't have like terms. That means that that is the answer of the exercise. Thanks for watching Simple Math, and see you in the next video. Bye bye.